I will try to repack my presentation because, fortunately, most of the technical stuff that I'm not able to to explain are already being explained by the more competent people than me. I will try to show the presentation from a perspective of a practitioner, like we are. And anyway, but before that, I just want to introduce the company. The company that acquired us is Engineering. Engineering is a global player of system integration. We are more than 11,000 people, and one of the strengths of Engineering is that we have 4 data centers where we host the data from many companies spread around the world and many administration here in Italy. Just a couple of months ago, Engineering came out with a new vision of the market, so we just restructuring our portfolio. So now we have 11 vertical solutions that are related to the world we live in and the world we work in, and are related to digitalization journey, so like smart agriculture, digital industry, and so on. But everything is based on a stack of different technologies. The most important is a digital enabler, so a normalizer that grab the data from our data center and let them usable for what an engineering call enabling technologies. So we are just focusing now on 8 enabling technology, and one of them is digital twin. So digital twin is where my team is working on, and we are mainly focused on digital twin application and forecasting and optimization. So following machine learning or classical operational research activities. These are just not the customer engineering, this is just the customer where we work for digital twin and simulation modeling. So now entering into the case, this is a Lagor is a small medium company in Italy. They just produce ferro-magnetic cores for power transformers. And they have for customers like IBB or Siemens, but they have very big problem in building these kind of massive products there. So just to let you know a little bit what we did, so the production of PT cores just start from coils of steel, where they cut and they stack one each other in order to reach the desired thickness for the purpose. And then this is done in this position. Then everything is done over some, we call it steel pallet. So the line is, since the weight of 8 tons is automated, and so everything is moving with some conveyors, some stuff, and stay on top of this steel pallet for the entire process. Another problem is that this steel pallet can never be removed from the line. So even if they are empty, they'll still stay on the line. So when the product enter into the line, stay there being stuck all the coils, all the layers of the steel, then come here, do some processing, come down, go there into the painting and curry station, different times depending on the production cycle, and then go here for the test. And then someone decided that the best way was going in the wrong way up here to the exit where they finish the process. So the problem is that this kind of production sometimes is done. The planning is done manually. So we are sequencing the production. They do it manually. And one of the stuff is that when it becomes to notice, so when they mess up all the stuff, the most practical way to resolve the situation is unloading everything from the line, reset the line, move everything back, and then put everything again on the line. So they come to us and they try to how we could solve this kind of problem. So first of all, our intention was to create a digital twin in order to, using agent-based modeling, so using AnyLogic, create a copy of their production system, getting the data from the field, and try to let to the production planner the ability to understand where the problem will be in the future. So using all the heuristics, we will try to understand this kind of point and make some correction for sure. So some of the elements that we reproduce, so we have the steel palette. As I said, these are the this white, black, blank square. We have the conveyors, and we have the cores that are moving around the line. These are all agents, but on top of that, we have a fourth agent that is the line manager. So the way we were working is like that. Anyway, I think in English it's the game of 15, something like that. Okay. So the idea is that he's moving all the things around the production in a centralized way. Okay, this was the best way that we found. And just to, oops, I messed up. So, okay. So this is a showcase just to let you know how it works. So this is the core that he has to move in the next station. So he has to move around there. So he's calling this conveyor to come down, get him, come up. So, but we have an obstacle there. So the obstacle should come down, go away, free the way to him to go to this final position. So this means that this should be a video. Hoping this works. Okay. So you take out the obstacle. Now it's finishing the job. So second obstacle away, freeing the way. Okay, now it's time to move to its final position. And this is another core that is working. So finally, we were able to produce that. So the customer was happy. Using a what-if approach, they were able to understanding the next future and getting in time, understanding how to solve and how to avoid possible collision or possible mess on the line. But anyway, this was based on heuristics, and we know very well that heuristics not always work. I don't even know, because this work was done by one of my colleagues, how we could implement all this kind of heuristic in there. There are very plenty of them. There is a massive piece of code in there. So sometimes even no matter how you engineer your heuristics, sometimes you have some unexplainable cases. So I'm guessing everybody came in that situation one day. So an example of a simulation limit. So in this case, the purple core should go down to the line and exit in this way. And instead, this blue one should go there and entering again into the painting station for another layer of painting. Okay? So the best way should be this one go down, just move this to steel palette away and exit, and then free the way for the other one. But the problem is that the heuristics say that this has the highest priority. So instead of doing something like that, let's see what happened then. Okay, so this should be the ideal case. Okay, so the core is going down. I want to get out of there, but this guy say, no, I'm high priority, so get out of your way. Now I want to come back. Now get out of your way. Still moving. So finally decided, not really. He wants to come back. But at the end, it worked. So finally, we were able to manage all this kind of complexity in there. And there is a lot of complexity, can I assure you. But sometimes we didn't have any efficient way to do that. So we were asking ourselves if there could be any alternative to solve this kind of problem, to optimize this kind of problem. For sure, we are coping with a sequential problem that is not easy to optimize. One way, anyway, is to explore the possible cases using brute force. Like, I don't remember if you had deep blue at the beginning. Even IBM at that time was able just with this kind of algorithms to go forward of just 6 or 8 moves, so not much more. Another way, can AI solve this kind of decision-making problem? We were already exploring AI for reinforcement learning and other stuff at the time, but this was on April last year. But then I came in with some very easy problem. But then I came in to Baltimore, and one very reliable guy, so Lily, said that reinforcement learning could be really applied. So if Lily said that, why not to try? So it's a man that we trust. So for sure, I have not to explain this one because we already talked about why we should enter in this game. Simulation modeling are the perfect gene for this kind of algorithms because we can create a realistic environment to train our models. But a lot of challenges. We said appropriate RL algorithm. So should I use DQN? Should I use tabular? Should I use FAC? So again, we were not expert into AI. We were just expert in simulation. We want just to try. So I think that anybody that is coming into this world should cope with this kind of problem. Which kind of algorithm should I use? Reward function. Should we spoon feeding? So should we dig a grove for our agent to learn or not? How to formulate the decision sequence? Is a centralized decision like we did before, or is something that is more a multi-agent problem? How to understand if I built a real high-quality environment. So I missed something. There is some dark angle that I didn't consider in my model. So this could bias the result of reinforcement learning. So again, observation space. We talked before a lot about a reward function because anyway, I agree. We smash a lot on this stuff. But even observation space is not easy. So what do I have to do? I just have to extract features from my environment. I just have to take an image, but maybe this is not the case. I don't know. So many questions come in place. Another one was one real problem is synchronize the two words. So I want to synchronize my simulation model with my reinforcement learning algorithm. So in the time I action on the model, I want to stop, get the environment state, pass to the net, waiting for the decision, and then come back. So everything should be real well synchronized. This was not easy at the beginning for us. And again, we talked before, so learning process is not easy to understand as someone honestly want to more, say that the problem stay in some bugs than in the result that you get from your reinforcement learning algorithm. So how to integrate that? For sure, we have a very good environment, AnyLogic, already there. We had some very good libraries in the world. Thanks, Guy, for the L4J. So this one that we use in this project because we were thinking that at the beginning, technology in this case can be, we didn't want to struggle much in technology, so we didn't want to care about how to connect Python to AnyLogic and so all the stuff. So we were thinking simple at the beginning, so we just used what it was already written in Java that could easily embed it into AnyLogic. And then you have to have very good people to work on that. This is a joint team with me and Decision Lab. So we are collaborating together for a long time, and I think that even in this case, we wanted to explore together this kind of new world for us. In this kind of example that I'm presenting, the guys that did the reinforcement learning were Ramin, and Roberto did the digital twin part. So simplify. So first of all, we wanted to understand how to cope with this problem. So we try to simplify the maximum at the beginning, so we have just one core, one steel pallet empty, and we want to give him to this position starting from any other point in the production line. So this was the case. So move away this steel pallet empty, move around this curing station, and it goes up to the target. So this is the training session. So it's just trying to move something without any understanding of what it was doing, because we take out all the heuristics from the model, and we had, in this case, maybe we started with a complex problem, because we had 64 possible action, and anyway, more than 36 million action state pairs. The only way that we were thinking to go, in this case, was a DQN instead of going with a tabular, because the number of dimensions that you have to take into account was so big, even for a simplified problem like that. But then, after a day or two of training, we were able to cope with this one. So look at this. It was moving around, moving everything, get to the target, fine. From any position, it was able to move and do the optimal sequence. But okay, then we decided to get a step further. So we tried to create an entire production cycle. We tried many different problem formulation, and at the end, the best one that we had was just to break the big problem into different series of targets. So the entire production cycle is divided into moving from one station or one point to another. So we decided to train different neural nets for each one of these targets, and then to join everything together at the end in order to have everything moving at the end. So this is the result, by and large. It is a simplified production cycle, but this is how it works. So it's going from, first he has to move to point 1. Okay, do some stuff. Moving again to point 2. In the same time, is moving away the steel pallet that is on its way. Again. So finally, this is the status where we are at the moment. We didn't finish yet the project. Anyway, this was something that we did internally for an investment. The customer didn't ask us properly to do reinforcement learning stuff on this digital twin. He's happy with his digital twin at the moment. But we wanted to test something. So what we learned from this example that we did is try to simplify for sure. Otherwise, you're stuck in a bigger problem that you can solve. You should design learning scenario and break everything in order to make, again, the problem manageable. And I didn't talk anymore about reward function and how to sell the project to your client, even if it, in my case, was an internal client, because I wanted to sell this concept to my boss in order to get the possibility to expand the investment on that. But again, we still have some questions that we were not able to gain. So how to formulate a good problem. There are many algorithms, which one to choose. Again, tabular, A3C, single versus multi-agent. There is not a big book of reinforcement learning. Anyway, we didn't find it. And other problems that anyway that are on the mind. So we think that at the end, the reinforcement learning is really promising, because on this kind of sequential problems, it seems to work very well anyway. It has good potential. But at the end, we think that everything should be on on a community because we need to join forces, and we did with Dave, we want to do with anybody else who want to join us and try to solve this kind of problem is well accepted. We will share, in some cases, John, we need to understand how this kind of model in order to let you know and let you open the code and understand how we did and what can be improved. So that's all. This is my email if you want to to write me. I'm very happy to answer you. Not too technical, please.
Thank you very much, Luigi. Quite impressive. My question is very simple, not technical at all. So what was the timeline of this project from the very beginning till the result you get without this machine learning?
Yeah.
And then the second phase where you used it? So just the timeline?
We had 2 months and a half. 2 months and a half for the project was starting in late April, late April, and ended in June. First phase, so only the digital twin. And I really, honestly, I think that Roberto did an amazing job on embedding everything. And this is I just showed the case where everything sometimes is not flickering, is not working well, but in many other cases it's working. And then we start looking at the reinforcement learning stuff by end of September up to February, but not full time for sure. Working on the. We want to continue with this anyway. The problem is big, so again, maybe we should need to change the technology at the moment because Java libraries, DL4J is a great library, but is not so complete at the moment as any other Python library you can find. So maybe they are more developed. This is what Andrei was saying about Python is better now because they have all this kind of stuff already. So this could be a solution to change the technology. But in my opinion, another important stuff is to maintain this kind of stuff easy for the user. So everything in Java, I love it. So instead of connecting many pieces together.
Thank you. Yeah, here. Part of the verification of your reinforcement learning was comparing it with the heuristic you already have in motion. And if it
yes, but the verification was quite simple because anyway, you could see in this simple case, oops, is working, play. No, maybe it's not working in the play again. So on this example, you could understand really well how it was moving and just counting the moves that it was doing. You can understand if you play step by step, you can see that the sequence is optimal. And the visualization helps you a lot in making the verification in this case.
And I mean, didn't you have like a more open space, like with more tests within it? I mean,
yes, we did more tests on that.
Yeah, and which metrics did you use to
which
show metrics? Did you use to show that how well your neural network was performing?
It was just looking at you mean after the training? Yeah. Yeah. So we understood that the training was going well because we were looking at we create a reward. The accumulation of reward that we were getting epic by epic, we were counting, and we were seeing that starting from a very low reward, at a certain point, something was growing. So the learning rate was the learning phase was going up, and then when it was stabilized on top, we were finishing. We were looking at. But again, breaking the problem in many different pieces was the breakthrough. Thanks.